Welcome back to the Deep Dive. Today we're going to be diving into the world of optimization techniques in business intelligence. Now, you're probably already familiar with how powerful data analysis can be when it comes to making smart decisions.
Right, exactly.
But sometimes, even with the best systems in place, finding that absolutely best solution can feel like you're trying to find a needle in a haystack. You know what I mean?
Yeah, absolutely. And that's where these optimization techniques really come in. They can really help us move beyond just analyzing the data and actually pinpoint the strategies that'll work best.
Okay, so it's not just about looking at the data. It's about finding that best strategy.
It's like, think of it like you're trying to navigate a really complex landscape.
Okay.
Every single peak represents a potential solution, but only one of them is the absolute highest, you know?
Okay, that's a great visual. I like that.
Yeah.
But how do we avoid getting lost when there's so many possibilities? How do we avoid just picking the first good solution we find?
Right. And you're right, a good solution might not be the best solution.
Exactly.
That's why there are techniques like simulated annealing, which is actually, you know what it is? It's inspired by the way that metals cool and crystallize. So you can imagine this process of slowly cooling molten metal. What happens is it gradually settles into this low energy, very stable state.
Okay, yeah. I kind of vaguely remember that from like chemistry class, but I don't quite see how that translates to like figuring out the best way to manage inventory for a business or something like that.
Okay, sure. So, imagine you start with like just a totally random arrangement of your inventory, right?
Okay.
And then you make these small changes, like shifting some items around, and then you evaluate that change. Did it improve our goal? Did it help us maximize profit, for example?
Right.
And sometimes what's really interesting is we accept arrangements that might temporarily make things a little bit worse, and this actually helps us avoid getting stuck at a solution that might seem good but isn't actually the absolute best.
So it's not always about making that immediate improvement. It's about kind of exploring the landscape, like you said, to make sure we find that optimal peak.
Exactly. And, another technique that kind of works in a similar way is called taboo search, and it helps us avoid getting stuck.
Okay.
Think about it like navigating a maze. You wouldn't want to keep going back to the same dead ends, would you?
No, absolutely not, no.
Yeah.
So how do we avoid those dead ends when we're talking about business decisions?
Well, we do something similar. We keep what we call a taboo list.
Okay.
And it basically has a list of the recent solutions we've already tried.
Right.
And we avoid revisiting them for a while. It kind of prevents us from going back and trying things that we already know don't work.
So it's like we're strategically forgetting some of the bad solutions so that we can focus on exploring new possibilities.
Exactly.
Okay, that's really interesting. Now, what about evolutionary algorithms? I've heard that term thrown around, but I'm not really sure how evolution plays a role in like business optimization.
Right. So imagine you have a population of solutions, let's say different ways to arrange products on a shelf, to maximize your sales.
Okay.
And we can actually breed these solutions together, like we combine the best features of each solution.
Wow.
And then over time, the fittest solutions, the ones that really work, they're going to survive and reproduce, and it leads to better and better arrangements.
So we're essentially simulating natural selection, but in a business context, to find the optimal strategy, that's remarkable.
Mm-hmm.
But what about in the real world where we have all sorts of limitations and constraints? We can't just pick the best theoretical solution, can we?
Right, exactly. And that's where this concept of constraint handling becomes really important. Think about it. You can't just ship products anywhere you want without considering the cost.
Right.
You have to factor in things like delivery times, budget limitations, even things like traffic conditions or how much space you have in your warehouse.
It's like a giant puzzle where everything has to fit perfectly together.
Yes.
So how do we actually incorporate all these constraints into these complex optimization algorithms?
Well, there are a few ways to do that. One approach is to use what we call penalties. Essentially, it's like adding extra costs to the solutions that break the rules.
Okay.
And that makes them less desirable. It pushes the algorithm towards options that fit within the constraints.
So it's like giving those rule-breaking solutions a little slap on the wrist, kind of. Are there any other ways to deal with these constraints?
Yeah, absolutely. So another approach is to use what we call repairs. So if a solution violates a constraint, we try to fix it. So for example, if a delivery route takes longer than the allowed time, we might try to reroute it to make sure it meets the deadline.
Okay, interesting. So we can either punish bad behavior or try to fix it. But wouldn't it be better if we could just avoid those rule-breaking solutions altogether?
Right.
Is that even possible?
You're thinking like a true optimizer. And that's where this concept of decoders comes in. Decoders are these really clever ways to represent solutions, and they guarantee that we only ever consider feasible options. It's kind of like designing a lock that will only accept the right key, you know?
That sounds really efficient. So we have these different approaches, punishing the bad solutions, trying to fix them, or designing a system that avoids them in the first place. So how do we decide which one's the best one for a specific problem?
That's a great question, and it often depends on the problem itself and the kinds of constraints you're dealing with.
Yeah.
Sometimes a combination of those approaches might be the most effective strategy.
It's so fascinating. It feels like we're building a toolkit to tackle even the most complex problems in business.
Yeah.
It's amazing how these techniques, they're inspired by things like cooling metal or natural selection, but we can apply them to business decisions.
It is remarkable how all of these different concepts, they come together and provide such powerful tools for solving problems. But, before we go any further, there's one more really important aspect of optimization we need to talk about, and it has to do with how we actually represent the solutions themselves in a way that the algorithms can understand.
Right. So it's like we need to speak the language of the algorithms to actually get them to do their work. So how do we translate these really complex business problems into something that the algorithms can work with?
That's exactly what we're going to be talking about in the next part of the deep dive.
Oh.
We're going to explore the world of solution representation and how it impacts how effective these techniques can be.
I can't wait. This has been really eye-opening, and I'm eager to learn more. To all of our listeners out there, be sure to like, share, and subscribe to The Deep Dive for more explorations into the world of business intelligence. We'll see you next time for part 2 of this exciting journey.
Welcome back to The Deep Dive. So last time we were talking about all these really cool optimization techniques, but they're only as good as the information that we give them.
It's like we need to give the algorithms a clear plan to follow, right? But how do we translate these messy real-world problems into something that, an algorithm can understand?
Yeah. It all comes down to how we represent solutions. Basically, we have to represent them in a way that the algorithm can work with. Remember that car distribution problem we talked about before?
Yeah, the one with all the cars going to the different auction sites.
Right, exactly. 3,000 cars going to 50 different auction sites. So think about it. One way to represent a solution could be just like a string of 3,000 numbers. And each number would represent the destination, which auction site a specific car is going to.
Oh, okay. So the first number is where car number 1 goes, the second number is where car number 2 goes, and so on.
Exactly.
Okay. I guess that's pretty simple, but what about all those constraints we were talking about? You can't send a luxury car to an auction site that specializes in budget cars, right?
You're exactly right, and that's where things get a little more interesting. We can actually build those constraints into the way we represent the problem to the algorithm. So, for example, maybe we make it so that certain numbers can't be used for certain types of cars.
Okay.
That way we ensure that only valid solutions, ones that make sense, are considered.
Okay, so we're not just randomly assigning numbers. We're actually thinking about the way we represent the problem so that it kind of guides the algorithm towards a good solution.
Exactly.
But with so many ways to represent a problem, how do we know if we've picked the right one, the best one?
Yeah, that's a really good question. It often comes down to a combination of experience and experimentation. Sometimes the best way to represent a problem is really obvious. Sometimes you need to try a few different things before you find what works best.
Okay.
But the key thing is to really understand the problem you're trying to solve, and also to understand how the optimization technique that you're using actually works.
So it's not just about the math. It's about understanding how to communicate the problem to the algorithm, speaking the right language. But can we see some examples of how this actually works in the real world?
Absolutely. So, one great example is in marketing. Imagine a company wants to get the most out of their advertising campaign, reach as many people as possible, but they have a limited budget.
Oh, yeah. That's a problem that every marketer faces, right? There's so many different channels, so many decisions to make.
Exactly. And this is where optimization algorithms can really help. They can figure out the best combination of, should we do TV ads, radio, online ads, social media, all those things.
Right. And they take into account things like who the target audience is, how often to show ads, how to avoid showing ads at the same time as competitors, all that kind of stuff.
So it's basically taking the guesswork out of marketing, right?
Exactly. It's letting data drive the decisions.
Wow. Okay.
Another great example is in manufacturing. So imagine you have this big factory floor, right?
Okay.
With multiple production lines, lots of different products. Each product has its own way of being assembled. It needs different resources.
Yeah, that sounds complicated. Keeping that running smoothly, that's got to be a logistical nightmare.
It can be, yeah. And this is where optimization can really shine. Algorithms can be used to determine the most efficient way to run the factory, figure out the best order for things to be done, how to assign workers and machines to different tasks.
Okay.
And they can even figure out the best physical layout for the factory to, reduce wasted movement and maximize the amount of stuff they can produce. So they're basically fine-tuning the whole production process to be as efficient as possible. That's really impressive. But these techniques, I'm guessing they can be applied to more than just physical goods, right?
Absolutely. One area that's really interesting is financial investments. Imagine you're a fund manager. You have to decide how to invest money across all these different assets, stocks, bonds, all those things.
Oh, yeah. Even managing my own personal finances feels overwhelming. Sometimes I can't even imagine doing that on a professional level.
It's definitely a complex task, and that's where optimization comes in. So algorithms can be used to analyze historical data, to try to identify patterns in the market, and they can make recommendations to the fund manager about how to best invest the money, taking into account their goals and all the constraints involved.
Wow. So it's like having a superpowered financial advisor.
Yeah.
Right? Crunching numbers 24/7.
That's a good way to put it, yeah. But let's look at another example where every second counts, emergency response. Imagine a city, right? And they have a limited number of emergency vehicles, ambulances, fire trucks, police cars, all of that.
Right.
And the question is, where do you position those vehicles so they can respond to incidents as quickly as possible?
Yeah, that's a life or death situation. I mean, optimization could literally be saving lives there.
Exactly. And that's where these algorithms can be really powerful. They can analyze things like past incident data, traffic patterns, where people live, and they can come up with recommendations about where to place those emergency vehicles to ensure the fastest possible response time.
It's like taking the emotion out of these really critical moments and letting the data guide the decisions.
Yeah. It's really powerful stuff. And, we've only just scratched the surface of what these optimization techniques can do. I mean, they're constantly evolving and people are coming up with new ways to apply them all the time.
Yeah.
But I think it's important to remember that optimization isn't about finding the absolute best solution, in some perfect theoretical sense.
Right, because best can mean different things in different situations, right?
Exactly. It's really about finding the best solution within the specific constraints and goals that we set. So it's really important to define those carefully to make sure that we're using these techniques the right way.
So it's a partnership between, our own intelligence, our goals, and the power of these algorithms. We set the boundaries, and then the algorithms help us find the optimal path within those boundaries.
Precisely. And as these techniques continue to evolve, we can expect to see even more amazing applications. But, before we get too carried away with the future, let's take a step back and think about what we've learned so far. What are some of the key takeaways from all of this?
Well, I think one of the biggest takeaways for me is just the huge range of applications.
Yeah.
We've seen how optimization can be used in so many different fields like marketing, manufacturing, finance, even emergency response. I mean, it's clearly a really powerful tool that can transform so many parts of our lives.
It really is. But just like with any powerful tool, it's really important to use it responsibly. I mean, optimization isn't magic, it's not a silver bullet.
Right.
It requires careful planning. It requires us to really understand the problem that we're trying to solve and to be willing to experiment and adjust our approach as we go.
So it's not just about, blindly plugging numbers into an algorithm. It's about asking the right questions, understanding the limitations, and making sure that we're using the right tools for the job.
Exactly. And, that's what makes this whole field so fascinating. It's this blend of, rigorous math, computational power, and human creativity. But there's one more really important aspect that we need to talk about, and that's the ethics of using these powerful techniques. That's actually what we're going to dive into next time on the Deep Dive.
Well, that's a topic I'm really interested in exploring more. To our listeners, be sure to like, share, and subscribe to The Deep Dive for more deep dives into the world of business intelligence. We'll see you next time for the final part of our exploration of optimization. Welcome back to The Deep Dive.
So we've been talking about all these amazing optimization techniques, how they're making businesses run smoother and even like saving lives.
Right.
But, as with anything that's really powerful, there are always those ethical questions that we have to think about.
Yeah, absolutely. We have to always remember that these algorithms, they're just tools, right? And they can only be as good as the information that we give them and the goals that we set for them. And if we're not really careful, we could end up accidentally creating systems that are optimizing for the wrong things, or they might even introduce bias in ways that we don't expect. That's a bit of a scary thought. It's like giving a really powerful machine a set of instructions, but we don't really fully understand what the consequences could be. So what are some of the specific ethical things that we need to be aware of? What are the pitfalls here?
Well, one of the biggest concerns is the data that we're using, If the data itself has biases, if it reflects biases that already exist in society, well, the algorithm is just going to learn those biases and it might even amplify them. So for example, let's say you're using an algorithm to help with hiring decisions, right?
Okay.
If the data that was used to train the algorithm contains historical biases against certain groups of people, well, then the algorithm might unfairly discriminate against those same groups.
So it's not enough to just have a lot of data. We have to make sure that the data is fair, that it's representative of everyone.
Exactly. And, another thing that we need to think about is the potential for unintended consequences. So, an algorithm that's focused on optimizing one specific thing, like, let's say, maximizing ad revenue.
Okay.
It might accidentally create problems in other areas. So, maybe it ends up prioritizing clickbait or sensationalized content, things that get people to click, but that's not really good for the spread of accurate information.
Right. So it's like we're optimizing for profit, but maybe at the cost of truth and accuracy. That's a trade-off that we have to be really careful about.
Yeah, absolutely. And it just shows how important it is to be really thoughtful about what we're asking these algorithms to do. We need to think about the big picture, not just the short-term gains, and we have to think about the long-term consequences of our choices.
It's a reminder that optimization isn't just a technical problem, it's a human problem.
Yeah.
It has social and ethical dimensions that we can't ignore.
Exactly. And that responsibility, it doesn't just rest on the shoulders of the people who are developing these algorithms, the data scientists and the engineers. It really extends to everyone who's involved. The business leaders, the policymakers, even everyday users like us. We all have a responsibility to understand these ethical issues and to speak up and advocate for the responsible use of these technologies.
It's a call to action for all of us to really pay attention to how these technologies are shaping our world, and to make sure that they're being used to make things better, to create a more just and equitable future.
I think our deep dive into the world of optimization has really been this incredible journey. We've explored all these amazing technical advancements, seen how they're being used in the real world, and also grappled with some of the ethical challenges that they present. We've seen the potential, but also the importance of using these tools wisely.
It's been eye-opening for me, and I really hope our listeners are, they're feeling inspired to learn more and to get involved in these important conversations about the role of optimization in shaping our future.
Absolutely. And, if you are interested in learning more about this, there are so many great resources out there, books, articles, online courses. You can even check out your local library. There's a whole world of information waiting for you.
And as always, be sure to like, share, and subscribe to The Deep Dive for more deep dives into all sorts of fascinating topics that are shaping the world around us. We'll see you next time for another exciting exploration.